right, guys, welcome to the room. I know we have some people trickling in, but check out the Emerging Tech channel on Discord for the link to the form for today's door prizes. Of course, you won't want to miss the amazing prize coming up later. And I'll share the password in a few minutes. We'll give it another minute or so for people to come on in. All right, let's get started. Welcome to the Fireside Chat, Technology Fireside Chat with Pandera. Thanks for joining us today, and I hope that you receive some insight that will help you both, professionally and on your solutions for this Aging in Place Innovation Jam. All right. Thanks again to our sponsors. Today, I'm joined by a panel of speakers curated by Pandera to go through topics like artificial intelligence, cloud computing, and more. I'd like to thank Pandera alongside our other sponsors for your support with the Innovation Jam. Pandera has set up our Google Cloud environments that hopefully you've been able to log into and start taking advantage of for the Innovation Jam. And two of our mentors are from Pandera as well. And they're on this presentation right here, Brian and Eric. So we'll hear from them soon. All right, here's that password for the door prize. Password is Google, all lowercase. And again, the link to the form is in the Emerging Tech channel in Discord. So make sure that you get your entry in and let us know if you have any issues. All right, now on to the chat itself. Want to introduce Brian O'Connor from Pandera. He'll be our panel moderator this evening. So thanks for joining us, Brian. Could you please introduce yourself and the panel?
Great. Hey, everyone. I'm Brian O'Connor, the Director of Solutions at Pandera Systems. So for those of you who have not heard of Pandera Systems, which I'd be kind of surprised if you have, we're a full service data analytics consulting firm, right? Our specialty is around data, analytics, machine learning, and cloud, right? We've partnered with the Go Studio team to help put on this hackathon for everyone, right? That would be setting up the cloud infrastructure. So if you do have any questions around your GCP environment, right, shoot those into the chat and we'll make sure that our teams can help handle that. On a personal side, I have a background in designing and developing machine learning algorithms at scale across a number of industries. So I'm excited today to be able to show you how you can use artificial intelligence and machine learning as a potential solution to help solve the problem of aging in place. And then I'd like to introduce Austin as well, who would be one of our four panelists. He is the head of client operations at Papa Health. Now, Papa Health is a telehealth startup based in Miami. They are paving the path forward for startups in the South Florida area, which if you've been kind of reading up on it, that is becoming a hot spot for startups and very fast growing. Now, Austin's going to be able to speak on the impact of telehealth for those that are aging in place. And then the third presenter would be Gordon Folks. Now, Gordon's the founder and CEO of Archer First Response Systems. Archer First Response Systems is a medical supply delivery system. They deliver first response packages via drones. So it's a super cool technology. And I'm excited to have Gordon share that with you guys. And then last but not least would be Eric Wilsey. So Eric is the CTO of Pandera Systems. So I'm all too familiar with Eric. We work alongside each other every single day. He is the true definition of a technologist. He's incredible at designing architectures and implementing solutions in the cloud. And I know he has some, very exciting and interesting architecture patterns to share with you that hopefully you can take into this hackathon with.
Awesome. Thanks, Brian. All right, one more time. The door prize password is Google. And this is an amazing panel. I can't wait to hear from you. So back to you, Brian.
Cool. Well, the way we're going to do this is everyone's going to have their chance to speak on their topic. We'll have about 7 to 10 minutes of presentation. Some of us will pull up some visuals, others will just be speaking to you. If you have any questions, definitely send them in the chat window. After everyone has gone, what we're going to do is open it up to Q&A. So, let's get started with it. I'm going to pass it off to Austin as he'll kick us off.
Cool. Thank you, everyone. Good evening or afternoon, depending where you guys are located. Brian, appreciate the warm intro. Excited to speak with you all here. As Brian said, I'm the head of client operations here at Papa. Papa, what we are a healthcare startup based out of Miami. Like Brian mentioned, really we're helping pave the way for startups here in South Florida. As everyone has learned, especially through the pandemic, there's talent everywhere. Especially here in Florida, and people are migrating to Florida not only for the warm weather, but also the accessibility of office space. We're super excited, building a really amazing office space here on the Miami Brickell River. So if you're in the area, please stop by, come say hi. Be super excited to show you guys around. Topic today is the company I work for, Papa. We are really what we go by as Family on Demand. I think it's really important to kind of go through where we started and how we came about, because as you guys are focusing on aging in place and building this challenge, you're looking for a problem space, and really a problem is in front of you at all times. So I'll take you kind of through that journey of how we found our problem and how it's developed really into an amazing startup and really a mission that we're so proud of today. So Andrew Parker, our CEO and founder, founded Papa in 2016, really out of concept, and it was out of a personal need, which I think so often is when the best companies and ideas are formed. Andrew at the time was running a telehealth company out of South Florida as well, and his grandfather, Papa, key the name, was aging in place, suffering from Alzheimer's, and needed a little extra support. Andrew, unfortunately, and his family did not have the time and attention that Papa needed to really be able to support his needs and keep him aging and safe at home. So it was the next step, dealing with a senior individual. What's the next step? Potentially a home healthcare agent, or bring him into senior living. Papa, as Andrew would describe him, was a very proud, self-sufficient man, but he was starting to regress more and more into his Alzheimer's. So the next step forward, they hired a home health aide, and Papa absolutely resented the idea. They had sent a home health aide over to Papa's house, and he hated it so much that he actually bit the home health nurse. It's funny to possibly us, but to them, that's a really difficult opportunity and to think through is now what's next. So the next state was, potentially sending Papa into a home, leaving him from being able to age in place. But before doing so, Andrew had this idea. A few doors down was a local college student. And he reached out to her and he said, hey, can you go hang out with my grandfather, take him grocery shopping, take him to the movies, provide mental stimulation, play chess with him, just be a friend to him. And this was kind of a light bulb moment. It worked out so amazing that Papa not only enjoyed and was able to stay safe and age at home, he loved it so much so that he started introducing this woman to all his friends and family as this is my granddaughter. So that was our initial slogan. Back in 2018, we went to market as Papa Grandkids on Demand. We launched as a consumer product. So myself, yourself, you could purchase our Papa services to send over a college-age student to go support a senior, provide daily living tasks, grocery shopping, things of that sort to keep them aging and supported at home. Really exciting for us, and which led to really the catalyst between the growth of our business is mid-2018, CMS, the Centers of Medicare and Medicaid Services, approved our type of companionship care to be sponsored by the government. So essentially what's that mean is now once a private pay company can now be sponsored and paid for, excuse me, I'm getting a call, can now be sponsored and paid for through health plans, much like a dental or vision benefit. So 2018, we went to market in our first health plan. We were able to launch our in-home support services. Fast forward to where we are today, we're live in about 28 of your most major health plans. And we are providing assistance now in 50 states. A service that was once traditionally in-home was challenged through this pandemic. So as you guys would imagine, and everyone's, had to deal through, was what are we going to do through this pandemic? How are we going to still support those that are socially isolated? So we were very fortunate that our partners saw the value of keeping seniors socially connected and engaged. So we actually transitioned our once in-home model to a virtual assistance program. So we started making outbound phone calls and video support chats to seniors with our Papa Pals, offering yoga services, offering cooking classes, just keeping them engaged. One of the key examples I think that we all saw like through a pandemic was getting to the grocery store. It was tough to us to get access to toilet paper, as an example, and that really affected seniors more specifically. So for us to be able to have a Papa Pal college age student go over to bring those services over to the senior was really an amazing and added benefit for them. Little bit snippets and kind of pop on what we've been able to accomplish. Most recently, we kind of look at our success and we measure our success on a loneliness scale. So we look at our cohort population and we assess them before joining our platform and see what is their level of loneliness. So we have several loneliness indicators that's able to give us whether they're lonely, severely lonely, or not lonely at all. And we've been able to validate that with the Papa intervention, receiving a Papa Pal, we've actually been able to make a significant impact on loneliness, social isolation, which is attributed to leaving and keeping seniors aging in place. So happy to answer any questions, go through the business model more in depth, but really excited to be here with you guys today.
Great. Thanks, Austin. I appreciate it. It's some incredible work you guys are doing over at Papa. So we'll transfer it over to Gordon then, who's going to speak on Archer First Systems and the technology that they have in place there.
Sure. Hey guys, Gordon here. I appreciate everyone tuning in. I look forward to kind of sharing a little bit about Archer and some of the technologies that we use. I'm going to share my screen here. There we go. Cool. Is that coming through all good?
Yep, you're good.
Awesome. I'm going to stop my video here so we can kind of keep our focus on the presentation. So anyways, so my name is Gordon. I lead Archer First Response Systems as its CEO. We're a technology company working to prevent fatalities from time-sensitive emergencies like cardiac arrest and opioid overdoses, a majority of which happen in the home, especially experienced by seniors in the home. So we're looking to really help prevent a lot of those fatalities by ensuring that they can get the access to the care and the treatment that they need. But we utilize dozens of technologies. And I hope to use this short presentation as just kind of a way to give an example of a solution that is greater than the sum of its parts, so that it hopefully kind of kickstarts your guys' creative minds as you work through this hackathon, and can maybe just at least be an example of a bunch of different technologies kind of put together to create a solution. Oops, there we go. Okay. So Archer First Response Systems is a 911 integrated drone deployment system. We focused on building all the necessary infrastructure that's required to allow 911 dispatchers to immediately deploy and transport time-sensitive lay rescue or medical equipment, specifically automated external defibrillators for cardiac arrest, Narcan nasal spray for opioid overdoses, and tourniquets for hemorrhaging events. So it all kind of starts with satellite analysis. So we actually download up-to-date satellite imagery from a company called planet.com. Such as an example of one of the technologies that we use. We lean on partners that have satellites in orbit and can get up-to-date satellite imagery. From there, we use a computer vision-based AI platform that we've built to help us understand what this imagery is, help us block out trees and rooftops and help us identify locations where it's acceptable to make one of these emergency deliveries. So for example, in this like short little like video clip, you can see, we put delivery coordinates in all the driveways, residential roads, golf courses, public parks, anywhere where it's really just kind of an accessible area to open to the open sky. And then we do this at scale. So we'll do this either across entire counties or for specific installations, which are about 35 square miles in total. So it's just kind of what those looks like. We next install our infrastructure. So this is kind of all of our hardware side of our company. We install this infrastructure directly at fire stations. Both our aircraft and our ground control hubs are IoT devices. They both use a suite of sensors and connectivity technologies that allow them and allow us to remotely monitor them and deploy them. So the aircraft themselves have a ton of sensors that help facilitate stable flight, GPS units, perimeters for altitude, electronic speed controllers, a whole bunch of different technologies in the aircraft themselves. And inside of our housing units, we use contact charging systems, temperature, humidity, pressure sensors, LTE cell modems for connectivity, and a few other technologies kind of inside of those housing units themselves. We've also kind of built backend infrastructure to help automate the monitoring and management of airspace, temporary flight restrictions, advisories, and weather. So that way 911 dispatchers can actually just focus on saving lives and not necessarily worry about whether or not it's safe to deploy one of these systems. So we really try and do our best to monitor live environment and automate the ability to either deploy or not deploy these aircraft based on, whether or not there is an airplane within the coverage area under a certain altitude, if there's a temporary flight restriction, or if, weather conditions exceed their accepted thresholds and so forth. We've also built third-party APIs and gateways to help facilitate the actual integration of all of this infrastructure directly into 911 emergency communication centers. This allows us to provide dispatchers with mission-critical information like accurate estimated time of arrivals for our aircraft making a delivery, or where the delivery is going to occur, if it's going to be in someone's driveway or at the intersection of this road or that road. And it also allows the dispatchers to deploy our aircraft with a single click of a button, kind of eliminating all of the considerations that one would initially assume are there when you're operating one of these aircraft. But instead, we're trying to basically provide a single click streamlined system to allow dispatchers to just utilize the actual utility of the aircraft, which is, obviously its athleticism, its speed, and its ability to fly directly over infrastructure. So all of these various technologies are rooted in various other systems. Basically, all of these technologies kind of bring value on their own. They allow, like, for example, all the technologies on our aircraft allow quick, safe, semi-autonomous flight. All of our backend infrastructure allows us to monitor real-time environments and automate whether or not a system could be online or offline, allows us to notify individuals that are part of the mission, or ourselves from a management standpoint of what's going on with the systems. The connectivity technology that we use allow the widespreadness of LTE cell networks really allow for that kind of consistent and reliable communication between our cloud infrastructure, our offices back here in Orlando, and all of our aircraft that are out in the field installed and at various different fire stations. And then also all of our edge computing devices allow us to actually remotely monitor and actually remotely deploy these aircraft and adjust their flights mid-route, and allow us to really have a hand on the pulse when it comes to every aspect of a mission. So each of these technologies kind of independently are very useful, but when you kind of combine all of these technologies and put them together in a cohesive way, the sum of all these technologies is really, really impactful. It's magic, really. We're able to provide 35 square miles of coverage with an average response time of 2.5 minutes. We're able to decrease response times and increase survival rates to specific time-sensitive emergencies like cardiac arrest and opioid overdoses. So, if a random person has cardiac arrest in their home and the nearest fire truck or the nearest ground-based asset is 6 minutes away, we're able to get a defibrillator to a cardiac arrest victim, in like 2.5 minutes or so. And so, yeah, so it's really cool, like being able to take kind of all this cohesive technology, tie it together, create APIs and gateways that allow the actual end user to interact with it, but not have to interact with the intricacies of the system. That way the utility of everything is, right within arm's reach of everybody. It's actually, within finger's reach of the dispatchers. It's a single click for deployment. And, they don't have to worry about all the other variables that are involved in the system. So that's what, in my mind, that's what a good solution is. It's one that's cohesive, utilizes the latest technologies that we have today to accomplish a end goal that when you see it happen, it looks like magic. You don't even, the end user doesn't even necessarily have to know all of the intricacies, the ins and outs of everything that you're building, but they will feel the results of what that solution is. So that's the most of what I got for this presentation. I hope it's been useful and it's been a good example of what is possible with all the various different technologies that are available today. And I hope it kind of unlocks a little bit of creativity and you guys as you're kind of working through this hackathon and looking to build solutions.
Great. Thank you, Gordon. So it is time to dish out a prize. I'm going to pass it over to Dustin and he's going to announce the winner.
All right, guys. Daily Double, we got 2 prizes today. So first on deck is the Stream Deck, Elgato Stream Deck. And our first winner is Monica Pack. All right. Congratulations, Monica.
Awesome.
We'll carry on with the other 2 panelists. Thanks.
Great. Congrats, Monica. So next up, we have Eric Wilsey to talk about cloud computing.
Hey, good afternoon, everyone. Can you hear me okay? Okay, let me go ahead and share my screen and let's see if that pops up. Can you see the presentation okay?
Yep.
Okay, great. Thanks. Hi everyone. My name is Eric Wilsey. I'm the Chief Technology Officer at Pandera Systems, and my focus and my time here in this session was really to talk a little bit about cloud computing, knowing that all of you are going to work hard towards building a solution to tackle aging in place. I thought it might be a good use to take my time to introduce you to some of the technologies and patterns that you might be able to leverage on the Google Cloud platform. And I want to first start off with a little bit of levity, right? And I've always liked this little sticker, this little meme, that says there is no such thing really as the cloud. It's just somebody else's computer, which is perfectly true, right? When we think about the things that you guys are going to build, or when we think about what Gordon just showed us from Archer Response Systems, he's leveraging a lot of computers, some of which were on the edge on his, in his control, but a lot of that was back end up in the cloud. And so, if we dig in, I've got a few architectural patterns. I don't quite know. I don't know what all of the different teams are thinking about in terms of what they might produce with their solution. So I curated a few slides to just demonstrate some of the the possible solutions you could build in the environment that we've provisioned for you on Google Cloud. And with this first one, IoT, which is right in the wheelhouse of what Gordon was just talking about, this slide makes it seem so simple as compared to what he was just showing us, which is far more complicated and far more in depth. But as you guys are looking onto the Google Cloud platform, one thing that you really want to think about when it comes to cloud computing is that first slide that I talked about, which was that you're just using somebody else's computer, right? And so when we look to the platform itself, you're going to find 80 to 90 to 150 different individual services that you might be able to use on the Google Cloud platform or a competitor if you go to AWS and Azure. And so what you really want to think about when it comes to cloud computing is, what is it that I need the computer to do, right? And then that tells you, going back to that previous slide, you're going to use somebody else's computer. And that's what Google is giving you. If we look at these different icons, are different computers that are configured to do something particular, right? And on the first first, the first step in an IoT solution is kind of an IoT gateway, a core, or a way that you can start to ingest the data from that device in there. All this is a bunch of specialized computers that are, tailor focused to solving that particular use case of IoT connectivity. And as we go to the right, we can see, well, once I get my data into the environment, whether that's sensor data or loneliness data or whatever that might be, we can use some commodity services on the Google Cloud platform to enrich or augment or cleanse that data. And there are managed services for that. Things like data flow and data prep are very common and ubiquitous in this environment, and so on and so forth. I'm not going to read off, each of the different components here, but I really just wanted to present, right, what are some of these things that you guys can leverage in your own solutions. If I move forward, where I started with IoT, here's an example, right, where instead of working with devices, maybe we're trying to, solve aging in place by analyzing data, right, finding a bunch of EHR or EMR data from a healthcare provider, ingest that, very similar process as an IoT device, right? Connect in or pull in some data. Google makes this very easy. They have what they call the healthcare API, which lets you easily pull in healthcare data from providers. That'll be a little bit difficult for you guys in a hackathon because you obviously have to have a relationship with a healthcare provider in order to ingest it. But the point really is that there are services on Google Cloud today where they will give you similar fake data that you can use to build your solution. And one of those is the healthcare API, where you can pull this data in. But just like with IoT, once we've ingested it, we're going to want to find a tool to transform that. And as you guys go and work on your tools, you're going to have a lot of options in the cloud, and especially Google Cloud. And that's where your mentors can come in and help you and identify what is the right product for me based on the particular scenario that I'm trying to solve, right, with your particular solution. If I move on to another example here, this one is a call center and chatbot. Maybe you want to build a solution, tackling that loneliness challenge where somebody can just call in or through voice command on an Alexa device or a Google Nest device, just have a conversation, right, to maybe kick off some other process or reach out for help. On Google Cloud, you have products like Dialogflow, which you can use in your solution to model conversations and topics that you might want to engage with your, the target audience or the end users of your application. And notice like that product in particular is what we call a PaaS. It's a platform as a service. It has a whole bunch of other capabilities inside of it. Things like sending out messages or switching the language, right? But you're going to also want to leverage other systems behind these PaaS solutions. Things like natural language processing to convert, speech to text, data loss prevention, maybe to scrub PII data if you're trying to, tackle that particular use case. And at the very end of that, BigQuery, which is a data warehouse, a good place for all of you as you're going to work with your data on Google Cloud. BigQuery is probably going to be a target or a product that you might work with. Lastly, I wanted to end this with one of the most complicated slides, which just tries to demonstrate that customers who come to the cloud, especially Google, you're going to end up, like this slide demonstrates, leverage a bunch of resources, maybe 12 to 20 distinct individual services. When we saw Gordon's slide and he was talking about his backend, it looked like I could read about 10. And I'm sure that was only a handful of the ones that he might have had. But really the point of this is, as you think about your solution and as you're thinking about tackling aging in place, you'll want to think about the different components and services that are available on Google and find the right one that's best for you based on the particular use case that you want. And that's where it goes back to understand the nature of that computer that you're going to be working with in the cloud. And if I move on to just the next couple of slides, I wanted to call out for you guys in your efforts as you move forward in your hackathon. I'm demonstrating or depicting some of the key products that you most likely will use. And these are all serverless products. These are things that are very easy to leverage, that you can just bring your code, whatever that code might be. Maybe it's a model that you've developed to analyze some kind of predictive propensity to be lonely. You can host that in cloud machine learning without knowing or needing to know how the computer underneath it works. Same thing with cloud functions. Those are very often used in hackathons because they're just lightweight hosts for individual logic that you might want to run. And the rest of these are all things that you're most likely to use. To hone in on that functions comment for a moment, here are a few depictions of what you guys might use these for. Things like IoT webhooks or mobile device webhooks to respond. If you're going to build a mobile app, right, using Google Cloud, and you want it to be reactive and to send out a notification, you're probably going to use a cloud function to be able to trigger that based on the data that you get, all the way over to things like content transformation. If you're going to maybe take a still image from a video and detect, has the person fallen in that video? Maybe we want to reach out for help. There are services out there that are specifically devoted to that. And you're going to use a cloud function to trigger that call to analyze that video. This next slide here really hones in on the different types of databases you might use for your hackathon and your solution. And I've called out here 2 that I've put an X on just to make it clear for you guys in the amount of credits that you have to run your hackathon. These 2 products, Cloud Bigtable and Cloud Spanner, are great products for when your solution might ever come to market and you actually fill it with lots and lots of data. But I would, encourage you guys to not bother touching these particular products in your hackathon solution, and instead focus on the other ones in that category, like Cloud SQL if you need a Postgres database, or Cloud Data Store if you're going to go with no document based databases, things like user profiles or just random data that you might want to store. And lastly, I really love this decision tree. This will help you guys understand as you're trying to bring your product to life or your solution to life for either a demonstration or to kick the tires. And by the way, all these slides will be shared. This decision tree kind of takes you down and lets you easily understand where are you going to host your code, right? If your code is you're only going to run it once because you're going to generate a finding and then that's your solution, that's not necessarily what this slide is focused on. This slide is focused on, let's say you're going to build a mobile app to monitor whether or not somebody has fallen down in their home, and you're going to deliver the alert in the mobile device, just as an example, right? This decision tree will help you understand, well, which of the products in Google would you actually want to host that on? And as an example, Firebase is a perfect one if you're intending to build a mobile app as part of your solution. And so that's all that I had. Thank you very much. I'll hand it back to Brian.
Great. Thanks, Eric. So hopefully by now, you have gotten some ideas for how to be creative to solve the aging in place problem based on what Austin and Gordon were able to share with you. And then you take that creativity and Eric be able to put you into a kind of a pathway forward for how to implement a potential solution or prototype in the next couple of weeks. I'm going to talk about artificial intelligence. Really my goal of this is to help get the juices flowing again with creativity, giving examples of how artificial intelligence, machine learning are being used across, the healthcare industry, as well as specifically aging in place and, caring for the elderly. And then I also am going to walk through some architectural patterns as well, which will hopefully tie it all back together, what Eric was just sharing. So I do want to give a reminder for everyone is if you have any questions from any of the 3 sessions or my session as well, or just for everyone, please throw them in the chat. We're going to be leaving hopefully 15 minutes or so to go through any Q&A that anyone has. So if you have any questions, that are written down, throw those into the chat and we'll make sure we address them as soon as I finish up this piece on artificial intelligence. Cool. So really what that is, what does, AI mean and how does it actually play a role in the problem we're trying to solve? Well, AI, and for those of you who haven't heard of AI, I think you're probably living under a rock by now, but kidding aside is, where AI is exactly what it sounds like. It's artificial intelligence, which basically means that a machine is performing a task of which previously required some type of human intelligence, right? So what that means is over time, artificial intelligence basically can learn behaviors and get smarter and advance, right? So when you think about artificial intelligence, a lot of you might immediately start thinking robots, right? And maybe that's just because the way it's portrayed in media or things like that. I think of the dancing robots. If anyone's seen the video with Boston Dynamics where like the robots are all dancing there, I forget what song it is, but it's a funny video, right? But like to get into artificial intelligence, you don't have to jump into, you know, engineering robots and, you know, actually mimicking human and social interactions, right? You could actually start relatively simple, right? And a common subfield of AI and it's actually the backbone of most AI is actually machine learning, right? And machine learning it solves thousands and millions of different use cases that you even see in your every single day life, right? So machine learning by definition is essentially training a computer or a machine to learn, right? Again, just like the way it sounds. So typically in machine learning, like I said, you don't have to, you know, start by creating a robot. And this is why I want to highlight this, because I do encourage the teams to actually try to put together a machine learning solution or an AI solution, right? So, you know, for example, some use cases that are pretty easy and basic to apply that you see across all enterprises is like predicting any type of customer behavior. Is that person going to purchase or not? Simple anomaly detection in healthcare, for instance, right? Cost optimization, fraud identification, right? And this is normally, you know, solved with structured data, right? So your columnar data, think CSV files, right? That can be solved directly with structured data. Now, it's very common to solve kind of these structured data problems, but machine learning also solves unstructured data problems, right? Which is becoming more and more popular over the past decade, right? And increasingly advanced, right? So when I say unstructured data, I'm talking images and text, right? So you solve that with computer vision and natural language processing, respectively, right? We've definitely have seen massive advancement in this space over, like I said, the last decade and like the last few years, like an accelerated gap, right? So, I mean, you notice it in everyday task, right? If every time if you have an iPhone and you have, was it Face ID enabled, every single time you realize like, wait, how's he catching me? I had my sunglasses and mask on, right? It's just getting better and better, right? Facebook notifies you that, you know, a friend posted a picture and it says, it's asking you if this is you. And you're like, yep, 100% of the time, I'm always the person that they're asking about. And I've actually never seen it wrong, right? Or like another example, right? I have an Alexa. I have to be careful saying her name or else she'll start speaking to me. But if I ask Alexa to play a song on Spotify, I don't even have to specify what song I want her to play. And Spotify will go back and choose a song that I really enjoy. And I'm like, yeah, this is great. This is exactly what I want to hear, right? So you see AI, machine learning, and everyone is well aware of this by now, but you see it every single day. And, you know, just over the past year, you could probably start to understand how much it is advancing, right? So when we think about this, I guess the question is, okay, what does AI have to do with, you know, the problem we're trying to solve? Right, which is optimizing aging in place, right? When we think about what are some solutions, right? It's, can we make sure that we do a better job monitoring our elderly while they're at home? Can we make sure that we're interacting with them so their lifestyle is improving, right? Their quality of life is a little higher. Can we do any preventative care to make sure that, you know, if no one's there, you know, are we putting in the right environment for them to be able to live by themselves, right? And not have to go to a nursing home or have 24/7 care, right? So when I think about that, I think one of the solutions is definitely health monitoring with AI. So health monitoring, right, can come in a number of forms. It can be real-time health indicators, right? And the backlash of health monitoring is going to have to be based on, you know, biometric monitoring, right? So if you think about your Apple Watch, I personally have a Whoop. There's a lot of, you know, kind of these straps which have sensors on them, attach them to your pulse or whatever the case may be, which actually scans, think IoT, back to Gordon's, you know, some of the parts or some of the architectures that Eric has shared. It scans your biometric data in real time within milliseconds, sends that data back to a centralized location on the cloud, and actually starts doing analysis on it, right? So when we think about monitoring our biometrics data, right, we're starting to understand the inner workings of what's going on in the biology of our elderly, right? So with that, we could get real-time health indicators. When we think about real-time health indicators, right, this could be, for instance, we might notice, what's a good example, like an alarming anomaly where immediate attention is required. So in real time, we could push data to the right. Maybe it's call 911, right? In a real-time alert. Maybe it's alert the family. Maybe it's alert the doctor, right? But that could be happening in real time just based on anomaly by constantly having models run in the background in your cloud infrastructure, right? That's exactly, similar, right? Maybe we could trigger Archer first response in that case. And then we send out the drone system and they have medical supplies, right? So if we think about, real-time health indicators, we could also think about predictive, right? So preventative. Now, this is where we really get into machine learning algorithm as well. Anomalies could be machine learning, but when we think prediction, right, it kind of goes hand in hand with ML. So we could predict risk levels for when it's time to maybe intervene and make behavior or environmental changes, right? So like preventative healthcare, think, right? An example of that would be a monitoring system of your data. Let's just say that you notice a steady decline in heart rate, right? Every day your heart rate's or over a course of, 6 months, your heart rate steadily, decreasing, right? Well, that should trigger a response, right? That should trigger, hey, we need to go check in on this person and do a checkup on them, or maybe we have to change their environment. Maybe we have to get them up moving more, right? And then the third piece, which is definitely on the horizon, is really recommendations, right? So we got real-time indicators, preventative indicators, and then recommending, right? Soon we should be able to create systems smart enough, and we already have started working on this, that should be able to automate recommendations based on your behavior. So, if I see that example where your HR is decreasing, right, we should be able to, if we're collecting enough data about this particular person, we should know, oh, your HR is decreasing, and what's the, what is the potential, causality of that or correlation of that in kind of more statistical terms would be, potentially they stop drinking water, right? Because we noticed that their water intake was down, right? So that's one way that we can use artificial intelligence for monitoring, the elderly while they're, aging in place, right? There's a lot of other methods. Computer vision is becoming very big where, it seems big brotherish, but like you can have videos in the house and then you can use computer vision to continuously analyze the video frames to be able to detect if a person is, kind of over time, gradually trying, like losing their balance, right? Taking longer to get up out of bed, right? Things that would require someone 24/7 to be watching you to kind of notice that, like, oh man, it's taking you a little longer to get out of bed. But great, now we could use computer vision technology to identify that without having to have someone in, your room, right? In the first early stages of the morning, right? And again, that could trigger preventative healthcare in a sense, right? Another thing is just connecting all these systems together. So you think back to the theme of Gordon's presentation around a sum of all parts, right? Is you can have a lot of connected systems, right? You could use video cameras, you can use biometric data and health monitoring. You could have sensors in your home. I have a friend who owns a water level monitoring company that tracks the water for a water usage, but it's really not an intended use, but you can use your water usage to understand, hey, how often are they getting up out of bed at night and going to the bathroom? Are they, are the bowel movements changing, right? Like things that are indicators of health risk. You can pull all these systems together, make it into a connected system like Eric has shown and what Gordon has shown as well, and really start to understand and become intelligent on who this person is, right? Again, it's kind of creepy and scary when you really think about how much we can monitor people. But the ability is 100% out there. And we're going to start to see this really impact the elderly population as we're starting to lose resources to be able to, manage our big boom of elders going into kind of retirement. So I'm going to go quick here because I do want to save time for a lot of Q&A. But, another thing is anti-aging. What I like to say is, and this is something I'm very interested in as well, is really more about longevity, right? And the goal now is, it's really not, simply living longer is not the goal anymore, right? It's living longer with your health, right? So, living to 100 is great and all, but if you're, dealing with chronic pain for the last 20, 30 years of your life, that's not the way you want to live, right? So when I think about this problem is, what can we do to actually solve anti-aging, right? When we think about it, like the actual technical term for it now is health span as opposed to lifespan, right? What is, my lifespan might be 100 years, but what is my health span? Is it 99 or is it, 70, right? So I think, problems that you guys can solve is, how can I use AI to potentially solve a healthier lifespan, right? And a preventative anti-aging, as opposed to, putting in monitoring systems to, put in place for someone who's already aged, right? So what I'd recommend is, sure, there's a lot of research going into like genome editing and stuff like that, which I don't expect anyone to get into. But like, for instance, a good place to start would be just doing research, maybe some type of correlation analysis. Grab a data set on blue zones. So if you aren't familiar with blue zones, those are like locations around the globe. I think there's 6 or 7 of them, where the lifespan and the health span are much longer than your average, right? You have people living up into their hundreds, and they're healthy, right? So you take a look at those blue zones, compare it to normal population, start doing some analysis on, their health span, right? So diet, are they active? Where are they located regionally, right? Start thinking about those variables that might impact longevity, right? And then as soon as maybe you'll solve something, maybe you'll find some analysis where, hey, there's a correlation between these factors and, people living a healthier life, right? And maybe that's your solution, right? So there's ways that, we can solve, anti-aging, for instance, right? As a potential solution to this problem. Another last thing is, quality of life. Now, this is something that Austin touched on, right? In his work with Papa, is their goal is they want to improve, not only be there, but they want to help improve quality of life, right? They think about companionship. Now, kind of all the rave for this would be chatbots, and companion robots, they call them, right? Someone to play games and interact with the elderly so they don't feel alone, right? But what else can we do? I'd like people on this kind of hackathon to think about is, can we create an application, for instance, that might develop triggers and impact behavior, right? If you think about it, every time, if you're on like Instagram or Facebook or any social media and you get a notification, these things are designed using machine learning, whether it's for good or for worse, to impact the way that you behave, right? Can we do something similar with the elderly, right? Can we create these social triggers that, gets them to stand up, maybe walk around, or, do something that is improving the quality of life, right? I urge kind of everyone to get creative on this for sure. And I have some architectural patterns. I want to leave time for Q&A. I have some architectural patterns that I'll make sure get shared out to the teams. And it's really just, how do we solve problems in Google Cloud, right? So it's pulling data sets into a BigQuery or a database, like Eric was mentioned, like a Cloud SQL, and then showing you how to use AI platform for being able to start, writing code in Python and analyzing the data and then building models on top of it, right? I'm a mentor for this hackathon. So is Eric. So if you have any questions, just feel free to reach out on Discord, and I could kind of help you understand how to, create an environment for machine learning development. Cool. Well, that's all I got for the presentation. It looks like it's time to give out another prize. So I'll hand it over to Dustin.
All right. Thank you so much to the panel. I hope you guys learned something, and we have questions and answers now. But first, a prize, AirPods Pro. I'm jealous of this one. Our winner is Rahat Rahman. So congratulations, Rahat. you have won some AirPods Pro, and we'll just get your address and get them shipped off to you after this. All right, so I have some questions building up, but please, if anybody has questions, put them inside of the chat. And I have, some people looking through the questions, and hope we'll get to everything. But the first question is for Eric, and really anyone on the panel can speak to it. But could you go, talk about how you would implement more emerging technologies besides your traditional like app development inside of GCP?
Sure. So when you're thinking about deploying, leveraging these new emerging technologies, things like AI and ML or IoT, all of these new buzzwords, what you really have to start with is take a step back and think about your outcome. What is your desired outcome? What are you trying to achieve? If you have a mobile device and you're wanting to surface next best action, right, on the mobile device to make a recommendation like Brian was just talking about, well, then we have to think about, and this is assuming to your question that it already exists. The tech stack already exists, right? If you know what the outcome is, then it's really just an engineering exercise to go back and figure out within that stack, what do I need to leverage in order to incorporate that functionality? Everything on Google is an API. So it's very easy in a modern tech stack to just reach out to a service and call it, right? To make a prediction and get back that value. Now, that belies some of the hard work underneath the hood, right? Brian was talking about making recommendations and predictions and things like that. To even build out that prediction requires a corpus of data. It requires some data engineering to make sure that your prediction is generated on clean, fresh data, right? So there is a lot of underlying work that you need to put in to solve the problem area, the domain. The engineering is actually the least complicated part of it, right? Getting it live in your app, is the development side is generally easy to do because it's, like I said, it's all just an API. But you might actually need to re-architect some of your own plumbing in order to leverage that external API, or to make sure that the feedback, the time, the latency, the quickness of the result might require you to invest in a lot more data infrastructure in order to get that speedy response. But yeah, I don't know if anybody else would like to add in any thoughts or.
Got it. Okay. Well, next one's for Austin. All right, about Papa. So you talked about social connection, right, with Papa. So can technology replicate some of that social connection, say like more at scale than pairing people up for one-on-one synchronous, meetings?
Yeah. So I think that's a great question, and it's something that we're learning, and our CEOs joked, and it now has come to fruition. Back when he was in a telehealth company, he always talked about, in order to get complete buy-in, everyone would have to get sick in order to realize that they needed tech. Of course, that happened. People were stuck at home. And a great example of getting, especially the senior space, involved in tech is these seniors that typically would be reluctant to signing into an iPad or an iPhone and speaking to a doctor or service provider virtually, we're now dependent on doing that. So I think the overall buy-in is not only there, but it's happening in front of us today. Additionally, to that, the one-to-one connection can be done virtually and remotely. And also, as I talked about earlier in my chat, is we've now been exploring into even this. I mean, this is a group channel that we're able to do via tech and still have very comprehensive and social connection, although maybe not the same as traditional. I think it's certainly there.
Awesome. Anything else to add? I know, Brian, you had talked about chatbots and that sort of thing.
Yeah, no, Austin definitely hit it all, but chatbots just in general are becoming the emerging technology to help with isolation. Whether that works or not, I think people like actual physical human interaction, especially in the older generation. So when I think about that problem, it's like I want to see people thinking bigger than a chatbot, right, to solve something, which is exactly what Papa's doing, right? So cool.
Yeah, and I would love to maybe ask Austin on that. I'm not too familiar with you guys' back end, but how would you say in your business, to whatever degree where is the data more important? Is it the computing? Like I mentioned, it's just another computer. To me, it's all just commodity services out in the cloud, right? The true value is the data, the algorithms, the product that you're developing, right? Would you agree, or what's your thoughts on that?
Yeah, no, I mean, at the end of the day, we are a data collection company. We are collecting so much data throughout this interaction. But to our core and what we promote, I mean, we are a mission-driven company. So externally, we're very much mission-driven and really making a social impact. But on the back end infrastructure side, the amount of data that we're collecting then in turn makes for a better experience, because we get to learn about their members, about the seniors, about the pals and the connection. And then we're able to really enhance that pairing process. Whereas without data, we could connect two individuals that are completely unalike. But with our data, we're able to connect really like-minded individuals and make for a really amazing pairing process.
Yeah, and that's awesome. And one thing I think all of the participants should probably think about for the longevity of their ideas, right, is the fact that at Google, like I don't work for Google, we're a partner of Google, but Google loves to say data has gravity. The more data you collect, the more data you're going to keep collecting, right? It's like a black hole that is just going to keep growing and growing and growing. And it's actually a double-edged sword. It can be your true business value, the thing that you're mining for insights, that your customers know you're mining for insights, but it can also be a complication, because as the data volumes grow, you got to pay for that, right? And in an architectural diagram, the cheapest component is the data when you start, right? But the largest expense is the computing power to process that data. So always think about longevity. How do we purge data? What do we actually need to keep? I don't know, those kinds of things.
That's great.
All right, got another question. Going to Archer First Response and Gordon Solution, and really to everyone about several technologies coming together to be greater than the sum of their parts. So what are some mashups of technologies for, say, like more non-emergent use cases, like reminding people to take their pills or exercise, or just have healthy habits, so that we don't get to the emergent use cases? What are some combinations and mashups that you think could be interesting for people to explore?
Yeah, I think there's a lot of just underlying infrastructure technology that really helps unlock a lot of the data capture that Eric was talking about, and on the edge side. So for us, even just kind of removing the emergency response side of it, at the core of what we've built is a drone deployment system, but one that you can utilize remotely, or one that you don't have to be in the room with it or outside with it. So kind of leaning on LTE connectivity, widespread broadband internet, and edge devices really kind of open the door to kind of being in the room without being in the room. I think Brian kind of even touched on that too, with his kind of big brother comments on hiding some cameras in his grandma's bedroom or something that he was talking about. But yeah, I mean, I think that there's a lot of just like really awesome infrastructure that everyone, not everybody, but a lot of people just kind of take for granted. You're driving down the highway and you see a cell tower and you just don't even think about it. You're just like, oh yeah, there's a cell tower there. But with like that technology in of itself, being able to connect all devices, whether they're just like your iPhone or your smartphone, all the way down to, for us, there's a barometer on our aircraft, so we know the altitude it's at, and I can connect that barometer to an onboard computer connected to an LTE network, connected to my cloud infrastructure, and now I know, no matter where I am, what my altitude is at with that aircraft. So I think like leaning on a lot of and I'm just like a big IoT guy. Like I was always fascinated by, like, I can click this button here and a lock 200 miles away is going to move. Like that just like blew my mind. And so I'm just like a big proponent of the Internet of Things and kind of being able to lean on a lot of the infrastructure like LTE cell networks that are in place. So combining LTE cell networks with edge devices, sensors, whether it's a camera, a light sensor, or if it's even something as simple as a motion detector, and then being able to derive information from that, that then you can start to ask, like, okay, what value can we learn from this now that we have access to it? So, I mean, for me, the biggest is just like, I'm just the IoT side of things, being able to have, you know, your hands all over the world without having to be all over the world, being able to ingest data in places where you can't get to and actually make actionable decisions based on the data that's coming in. So yeah, so just a lot of it for me is edge devices, edge computing, and cell networks. I think they're magic, and they really unlock a lot.
Awesome. Well, I hate to say it, but we are out of time now. Definitely hop on Discord, and don't forget, we have the mentors that can follow up with any additional questions or recommendations. So yeah, thanks everybody for joining the panel today, and thank you panelists for being here as well. Hope that everybody learned something and can take it back to how they're solving the challenge. I want to do a quick reminder about our next event, Tuesday, April 6th from 6 to 7 EST. The topic is on truths in innovation, moving fast and putting humans at the center, and it's hosted by our sponsor, EPAM. Again, at 6 to 7 p.m. EST, Tuesday, April 6th. So thank you again, and good night and good luck.
Thanks, everyone.
Thanks.